All right, ladies and gentlemen, let's continue to look at some of these special situations when it comes to factoring. So here we have two sets of trinomials that we are going to factor. So we're actually just going to go through the process because there are three terms. So we are going to set up our X puzzle, draw our box, and go from there. So for our box, we would have X squared here, 9 here, or plus 9 here. So we need a product of 9 and a sum of positive 6. So when I go to set up my two binomials, I know I have X and X. Everything is positive, so we'll keep it that way. Product, so factors of 9 that will give us a sum of 6. Well, hello, 3 and 3. So these two end up being exactly the same. So then this would be a 3x here, 3x here. So we would end up with x plus 3 squared. Next one we'll do exactly the same way, and hopefully you're kind of picking up on how the process works for this one. So again, X puzzle, my box, 49 here, X squared here, 49 here, and negative 14 here. So this is going to be a little bit different because of that negative. So I have X here, X here. Now I have a positive product but a negative sum. So that means both of these signs will be negative. Now I need factors of 49 that will give me a sum of 14. So we're looking at negative 7 and negative 7. And keep in mind, you can always multiply x squared minus 7x plus 49 to see if these two middle terms give you what you need. Usually it's the middle ones that are the tricky. So here would be what we have, but to simplify that, we would have x minus 7 squared. Okay. All right, here's another one. This is kind of a real life situation in a way. They're saying the area of a patio is 16m squared minus 72m plus 81. What is the length of one side of the patio? So again, it's square. So that means it's going to be the same on all four sides. So we know that, let's see, we're going to use a shortcut on this one because those values are kind of crazy. So I'm going to take that first term. I have 16m squared, and I'm going to square root it. So this would be 4m, right? I'm going to do the same thing with 81. I'm going to take the square root of that, and that's 9. Now this term right here tells us that it's subtraction. So let's see what happens if I multiply 4m minus 9 times 4m minus 9. So 4m times 4m would be 16m squared. 9 times 4 is negative 36m, and then plus 81. So these two middle terms actually do have a sum of negative 72. So it is correct that it is a square trinomial, or a perfect square trinomial. So this would be 4m minus 9 squared. They're both the same binomial. I know I went through that one kind of quickly, but if you ever notice that it's one of those perfect squares, then you can definitely go from there. So now we have a different situation. Here we have where we're missing that middle term. So you're going to want to create a middle term of 0. So now you can do your box and your X puzzle. So this would be v squared, negative 100. So negative 100 here and 0 here. So it's going to be 10 and 10. One positive, one negative. And we know that because this needs to have a value of 0. So we know we're going to have one of each. So when I create, I'm going to have plus 10, minus 10. This will be our pair of binomials. And again, you can factor these guys out this way. So let's look at this last one. Let's kind of take it into like a shortcut so to speak. So if you take the square root of the first term, that's s. If I take the square root of the second term, that's 8. So wouldn't it, not 8, wow, that would be 4. So wouldn't it make sense, because that middle term is missing, that they would be the perfect squares of the first and last term? So let's see what we got here. S squared minus 4s plus 4s minus 16. So these two would cancel, so we'd be left with s squared minus 16. So yes, these are the difference of two squares. All right, here's another one of those difference of two squares. So same idea, we're going to take the square root of the first and last. So this would be 5d and 8. We're going to have one of each. So 5d minus 8. When you have that situation, then you're good to go. So we can check this though. So this would be 25d squared minus 40d plus 40d minus 64. So then these two middle terms have a value of 0. So yes, we're left with what we need. All right, let's see what we got here. Now, sometimes it's not always like that. In this case, I do have a value I can factor out of there. I can take a 12 out. So I'm left with t squared minus 4. Now, I don't know about you, but I'd rather work with t squared minus 4 than 12t squared minus 48. So we're going to go into our shortcut. So 12 is going to hang out front. We're going to have t plus 2 and t minus 2 to give us our difference of two squares. All right, let's check out this one here. So if you notice, all of these are divisible by 3. So I'm going to factor out a 3. So we'll have 4x squared plus 12, plus 4x plus 1, right? Because 3 times 1 is 3. But when I go to do my x puzzle in my box, I need a product of 4 and a sum of 4, both positive, right? So you would think it'd be a plus 2 and a plus 2, but watch what happens. So this would be 4x squared, and this would be a plus 1. So when I do plus 2x plus 2x, I would go factor out a 2x here. I'd factor out a 2x here, so maybe plus 1 right here. And plus 1 right here. So let's see what happens. If I have 2x plus 1 times 2x plus 1, so we would end up with, let's see, 4x squared plus 2x plus 2x plus 1. So when I combine my two middle terms, I get that 4x that I'm looking for. So then we would have a situation like so. Where we would have the 3 hanging out front as well. So we could also write it this way, 3 times 2x plus 1 squared.